Hello everybody, we are going to be covering adding and subtracting polynomials, and as you can see right in the middle of this is a picture of my students as they start this video. I know you're excited, so I don't want to keep you waiting for very long. Now I will tell you that picture also has a secondary reason for being here. So we've talked many times about Mr. Schmidt chaperoning a middle school dance, and as you know, I like to keep boys and girls separate on different sides of the room, keep everybody separate. And we use that as an analogy for variables, that we always talked about having x's and y's are a lot like boys and girls at a dance. We want to keep them separate. So, you know, if Mr. Schmidt's actually chaperoning a dance, we like this nice and separate. They can stand next to each other, but absolutely no touching. So, as we look at these problems, I want you to think about, instead of just boys and girls at a dance, I want you to think about like colored shapes. So as we have this crazy mess of a problem, this is a lot like an equation, okay? And so we have 4 red circles that we can regroup and draw together. We have 5 black triangles that we can regroup and draw together. And then we have 3 rectangles that we can group and draw together. Now, we would not combine these together, and we have 5 here, 3 here, and 4 here. No one would combine these together and say, we have 12 triangle, rectangle circles. Like, that doesn't make any sense. You would say we have 5 triangles plus 4 circles plus 3 rectangles. And as we look at our equations and our problems and polynomials later, I want you to think of them in the same way. You can't combine triangles with your circles. You can't combine your circles with your rectangles. So here's our first problem, that we have x's, y's, and regular numbers. And before I start doing anything at all, I want to think about, okay, so what variables do I have in this problem? So in this one, I have x's, y's, and numbers. So first thing I want to do is I take my very first variable, which is x's, and I want to underline it. And I want to underline every other x term that is in this equation. And I only see one right here. So I see x, and then we're good to go. Now I go to the next variable, which in this case is y, and I want to do the same thing. Let's underline every other term that has a y with it. And there's only one. And finally, our last term, which is -5. Same thing. And I also see -8. So I now have identified every term. And now I want to combine what can be combined and separate what can't be. So my x's, I have 3 x's and 5 x's. And they combine together to give me 8 total x's. Next, I combine my y's. I have +4y, +6y, which gives me a total of +10 y's. Now, the hard part here with the negatives is I want to combine -5 and -8 together, which gives me a combined total of -13. And that's as far as I can combine, because I can't put x's and y's together. I can't put x's and numbers together. So we are fully simplified. Now, you might have put the y's first. In that case, we would have 10y plus 8x minus 13. And that would be correct as well. You also could do something like -13 plus 10y plus 8x, and that would be correct as well. All of these are the same as long as these signs are always the same. So the 13 is always negative, the 8 is always positive. So now we can get into the terminology of a polynomial. And when we know the word poly, or hear the word poly, this means many or multiple. So polynomial is many nomials. And nomials, as a term by itself, simply means terms or items. So in a math context, polynomial is an equation or an expression with many terms. Now, if we're looking at a monomial. Mono means one. So this would be one term. If we had binomial, bi means two, like bicycle. So this means two terms. You can do trinomial, but most people from this point start talking about polynomials, which just mean many terms. So if I ask you to add or subtract the following polynomial, what I'm really asking you to do is simplify an expression or an equation with many terms. So here's an example of a pretty complicated polynomial because this has many different terms. And one of the first things I want to do is I want to identify what can be combined with other things. And here's where it gets tricky. So I have 3x squareds. X squareds are not the same as x's because if I think of the number x as, let's say, 3, 3 squared is not the same as 3. Therefore, x squared and x's are not the same. It also means then y squared is not the same as y cubed because 2 squared is not the same as 2 cubed. This would be equal to 4, and this would be equal to 8. So any term squared, cubed, or cubed to the 4th power, anything like that, are not the same. And if you show me this section of your notes, I will give you 5 SPs for clarifying that. So the first term we had was 3x squareds, 3x squareds. And I want to combine it with all of the other x squared terms that we have in this polynomial. But I have y's, regular numbers, x's without squared, and y squareds. So this cannot be combined with anything else. 3x squared is my first term. The next term is y's, 4 regular y's. Cannot be combined here, cannot be combined here, and this is y squared, so it cannot be combined there as well, which means our next term stays the same as well. Our third term is the regular number -6. Well, regular numbers can only be combined with other regular numbers, so this also stays the same. You might be figuring out a pattern from here because 6x also cannot be combined. So I get 6x. And finally, the last term is y squared. 8 of them cannot be combined with anything else. So I actually have this polynomial cannot be simplified, that it stays exactly the same. And I will give you a lot of problems like this. Now, most people do not write in this order because this order looks really random. What they will do most of the time is they will write in what we call descending order. Descending meaning big to small. So that would mean I would start with my x squareds. The next term would be my x's. And then I don't have any other x terms after that. So then I would write my y squareds, my regular y's, and then I would be left with my very last number. But I'll tell you, these equations or expressions are exactly the same. Just because you're writing it in descending order does not mean that the problem is any different than before. Let's do one last problem here. So, first thing I want to do is I want to underline my first term, which in this case is 1y squared. And I want to combine that with all of the other y squared terms, which in this case is right here. I have positive 3 y squareds. I can combine those together to make positive 4 y squared terms. There are no other y squareds in this expression, so I go to my next term, which is 1 regular y. I can combine that with -6 y's over here, and finally 8 y's over here. 1y minus 6y is -5. -5 plus 8y is positive 3y. And for us, this is actually already in descending form because y squared has a bigger power than regular y. So this has been adding and subtracting polynomials. As a quick review, make sure you keep all of your terms separate. You also need to make sure you remember polynomial just means many terms. So when I say adding and subtracting polynomials, I can mean many, many, many different types of expressions and equations. As always, if you have any questions, please let me know.